So, hi everyone, my name is Shivam Bohra. I'm a third year computer science engineering student from Dehradun. I love solving problems and I also love to teach. Welcome to our channel, Learn Competitive Programming with CodeChef. So, if you are interested in competitive programming and want to learn and master data structures and algorithms, then this is a one stop destination for you. Here we post weekly problem explanations, conceptual videos on various programming paradigms, and also conduct live problem solving sessions. So before we actually get started, here's a reminder for you to hit that subscribe button if you haven't already yet. So in this video, we are going to solve college admissions which appeared in Feb Starters 2021. The difficulty level is easy to easy medium and the prerequisites are sorting and greedy algorithm. So the problem statement says that we have n number of colleges and m number of students and the ranks of both colleges as well as students are given to us. So over here, the indexes of the respective arrays represents the IDs. That is, the indexes over here on the left hand side represents the college ID, and similarly the indexes over here on the right hand side represents the student IDs. And the college having college ID 2 over here is the best college, and similarly the student having student ID 3 is the best student in this array. So according to their ranks, the students are going to get their respective colleges. And at student ID 1, this particular student is chef, and the question or the problem statement wants us to find the college ID in which chef is going to get in. And if it is not possible for chef to get a college, then we shall simply print 0. Now the most important part is all these M students have a list of colleges in which they are going to apply in, right? That is, for the first student, he is going to apply in 3 colleges. That is, the student is going to apply in k different colleges. And for this particular student having student ID 1, he is going to apply in 3 different colleges. And these are the college IDs of the colleges in which he is going to apply in. Similarly, the second student is going to apply in 2 different colleges, and similarly, the third student is going to apply in also 2 different colleges, right? So talking about the first student, he is going to apply in 3 different colleges. And this is the list of colleges in which he is going to apply in. So out of all these colleges, he will try to get the best possible college that he can, which means that if there are 3 colleges over here, then he will try to get into the best ranked college which has a vacancy, right? Now the student at student ID 1 is none other than chef. So if he is able to join a college, then we shall simply print the college ID of that particular college, and that would be the answer of this case, right? So talking about this student, what I'll do is, firstly, I know that he wants to get into these 3 colleges, and K is 3, that is he wants to get into 3 colleges, and these are the college IDs of the 3 colleges in which he wants to get in. So out of these 3, we already know that 2 has already been allotted to the student 3. So we can cut this 2 from here. So now we are down to 2 different colleges. So coming over here, we are down to 2 different colleges, which are these 2. So out of these 2 colleges, which is a better college or which is a better ranked college? The answer is simple. This is a better ranked college having college ID 3. So, and this particular student is none other than chef, and he is going to get into this college having college ID 3. So 3 would be the answer for this case. So moving on to the approach, firstly, I'll create this college rank and the student rank array, right? Then we will input the college rank and the student rank array. And after that, we need to store the list of the colleges of each and every M student in which he is going to apply in, right? So now we know that the first student is going to apply in 3 different colleges which have the college IDs 1, 3 and 2. So now what I'll do is I'll sort this array in such a way that the college which has the best college ID or the college which has the highest rank comes first, right? So out of these three colleges, which is the best college, right? So out of these three colleges, we can see that the college having college ID 2, this particular college has rank 1. So this is the best college among these three. So college having college ID 2 is the best college over here. After 1, we have the second best college is at index 3 or at college ID 3. So after 2, 3 will come, and after that 1 will come. So we will sort this particular array in such a way that in such a way that the best college comes first or the best ranked college comes first, right? And similarly, I'll sort this particular array 1 and 2 again in such a way that the best ranked college comes first. And similarly, I'll sort this third array in such a way that the best ranked college comes first. So now we can see that we have three different arrays of three different size. What I'll do is I'll store all these arrays and form a 2D vector or a jagged array, right? Because in a jagged array, we can have different number of columns for each row. As you can see that this particular data structure has a different number of columns for each row. This one has 3 columns, this one has 2 columns, and this one also has 2 columns. So what I'll do is I'll store all these numbers into this 2D vector or 2D jagged array. So now we have made this 2D vector or 2D jagged array in which the first row represents the preference list of colleges of the first student or the student at student ID 1, and the second row represents the preference list of the second student, and similarly the third row represents the preference list of the third student, right? After that, we need to allot these colleges to the students according to their ranks, right? Which means that the first ranked student should get his college first, right? But if I sort this vector or array, I'll lose their indexes, hence their student IDs. So what I'll do is I'll just store the indexes of this vector or the student IDs of this vector, which is nothing but numbers from 1 to m. So 1, 2, 3 I'll store over here. After that, I'll sort this vector in such a way that the best ranked student comes first, right? So over here, the best ranked student is this particular student, which has the student ID 3. So 3 will come first. Similarly, after 1, 2 will come. So its student ID is 1. So after 3, 1 will come and then 2 will come. So I'll convert this array into such an array in which the best or the best ranked student comes first, and I'll name this array as rank wise index or rank wise array. So till now we have made this 2D vector or jagged array and this ranked wise index array, right? So this 2D vector or jagged array tells us about the preference list of the students, right? And this has been done serially, or the row over here or the row number over here represents the student ID. That is, if we are talking about the third row, it means that this third row is the preference list of the student having student ID 3. And we have discussed about this ranked wise index array, in which it means that the best ranked student in this array is at index 3 or has student ID 3. The second best student over here is at index 1 or has student ID 1, and the third best student over here has index 2 or has student ID 2. So to allocate the colleges, what I'll do is I'll create this allocate array in which I'll initialize it by 0. Over here, 0 means that the particular college has not been allocated to any student, and 1 means that it has been allocated to some student, right? So initially, what I'll do is, firstly, I'll allocate the college to the best ranked student. And we know that the best ranked student is at index 3 or has student ID 3. So currently we are talking about this particular student. Now to get the preference list of this particular student, I need to go to the app or the application to the vector, and over here to get the preference list of the third student or the student having student ID 3, I need to go to the third row. So over here, this third row tells us about the preference list of this particular student. So given an opportunity, he would like to go to the second college or the college having college ID 2. So he would like to go to the second college or this particular college, right? So firstly, I'll check whether this college has been allocated or not. So in this array, we can see that 2 has not been allocated yet. Its value is 0. So we can simply allocate this particular college to this student. That is the student having student ID 3. So what I'll do is, after allocating, I'll rewrite this 0 as 1, which means that this particular college has been allocated now. So after 3 will come on to 1. That is, this is the second most worthy student now, or the second best ranked student, right? So to get the preference list for this particular student, I need to go to the first row of this 2D vector. And this is the preference list for this student. So now we can see that firstly, he would like to go to the second college, right? And we can see that in this allocate array that the second college has already been allocated to another student. So second college is not available for the student. So he needs to go to the other college. So he'll check. So now we'll check it for 3. So we can see that for the third college or the college having ID 3, this particular college has not been allocated yet. So I'll allocate the college 3 to the first student or the student having student ID 1. Also, the student at student ID 1 is none other than Chef. So we can simply print 3 at this moment and we can simply stop our code, right? Now, initially, what I'll do is I'll set a variable f equals to 0. And at this moment, when the student having student ID 1 joined a college, now at this moment, I'll set f equals to 1 because it means that Chef has finally joined a college, right? And if after iterating for each and every student, if the value of f is still 0, it means that Chef didn't join any college. So we can at the end we can check that if f equals to 0 or not. So if this condition is true, it means that Chef didn't join any college. So at the last we can simply print 0. And if you want to master data structures and algorithms, or if you want to excel at competitive programming, or if you want to do really good at coding rounds as well as coding interviews, then you should consider watching the courses conducted by CodeChef itself. Now there we have many beginner level courses like Introduction to C++, Introduction to Java, and various other beginner level courses that would be taught from the very scratch. And we have very advanced level topics like dynamic programming, trees, segment trees, graphs, try, etc. Right? And you will be taught by really good educators like those who have cracked big tech companies or those who have cracked big CP competitions like ICPC, INOI, etc. etc. Right? And to watch these courses, you'll find a link in the description, and while registering you can use my coupon code, which is white magic 333. So moving on to the code, firstly in the main portion I'll input t, which is the number of test case, and then for each test case I'll call this solve function, right? Then I'll input n and m, which is the number of colleges and the number of students, right? And then I'll create this C rank, which will store the ranks of the in colleges according to their college IDs, and I'll create this S rank array which will store the ranks of the M students according to their IDs, right? So from 1 to n, we have n IDs of the college, and at their respective IDs, I'll store their respective ranks. And similarly, from 1 to m, we have m students having m students having IDs from 1 till m, and at their respective IDs, I'll store their rank, right? So after this, I'll create a vector of vectors to store the applications of m students. And about this comparator, I'll talk about this comparator in a minute. So now we will input the applications of m students. So here we have an array from 1 till m, right? So for each student, we know that we have k applications. So firstly, I'll input this k, and then for k application, I'll create a vector of size k. Here I'm writing it as id because in the application we'll get the id of the college in which he wants to apply in. So let's say if k is 3 and these are the three colleges, college or the IDs of the three colleges that he is going to apply in, and if these are the ranks of the respective colleges, then we know that if these are the three colleges, then firstly he would like to go to the best college, or his first preference would be the best ranked college among these three. So we can see here the college having ID 3 is the best college, the college having ID 2 is the second best college, and the college having ID 2 is the worst college, right? So 3 will come first because it is the best college. So it is the so this college is the student's first preference. Then 1 will come second because after 3 the best choice for student is the college having ID 2 because this is the second best college, and then the third best college for student is the college having ID 2, right? So after sorting this array using the comparator in which I'll compare the ranks of the respective colleges, I'll sort this vector ID vector in such a way that the best college comes first, right? So now we have sorted the college IDs according to their ranks, and this is the preference of application, or the this is the preference of the student. So this is the ordered application for the current student, right? So what I'll do is uh, over here where we had sorted the ID array, after this I'll store this ID vector into this app of I, which means that for the current student the ordered application is stored in this ID vector, right? So after this, firstly what I'll do is we know that we again have to sort the students according to their ranks, right? So firstly, I'll create an vector, or I'll create a vector with just ranks from 1 till m, because we know that with indexes from 1 till n, because we know that this is the student rank array 2, 3, and 1, and the student ID for the first student is 1, that is the student having rank 2, his student ID is 1, the student having rank 3, his student ID is 2, and the student having rank 1, his student ID is 3. So firstly, I'll create a vector with from 1, and I'll assign its values from 1 till m. So firstly, I'll create this rank wise index vector of size m, and I'll assign it from values from 1 till m, right? So 1, 2, 3 are assigned to this rank wise index vector. Then I'll sort this rank wise index vector in such a way that the best ranked student comes first, because we can see over here that the student having student ID 3, his rank is first, so he should come first. So I'll sort this RWI vector in such a way that 3 comes first because it is the best ranked student. So after 1, the second best student over here is the student having student ID 1. So after 3, 1 will come, and after 1, 2 will come, right? So we have sorted this rank wise index array in such a way that the best student comes first. So now what I'll do is I'll allot colleges to the students. So I'll create this allotted vector of size n plus 1 and I'll initialize it by 0, which means that initially no college has been allotted to a particular student. Then we will allot these colleges to students on the basis of their ranks. That is, the student who got a higher rank, he will get the chance to get his college first, and the student who got the lowest rank, he will get his college at the very last, right? So we will iterate from 1 till m, and I'll store the student ID of the student who got the first rank over here, right? Rank wise index at I minus 1. So we got the student ID of the student who got the rank, who got the first rank. So after this, we know that that particular student, he must have given k applications to k colleges. So to get the value of k, what I'll do is app of student ID dot size. This will give us the value of k for this particular student. So after this, we can get the college ID, or after iterating from 0 to this app of sid dot size, we can get the first preference of this student, right, at app of sid of j. And after that, we will check if allotted of college id is equals to 0 or not, which means that if this particular college having this particular college id, if it has been allotted or not, or its value is 0 or not. So if it is 0, which means that this college is free and it hasn't been allotted till yet. So what I'll do is I'll simply first allot this college, and I'll set allotted of college id equals to 1, which means that this particular student has got this college, and we can simply break this inner loop. Also, I'll check if the student ID is 1 or not. Now we know that Chef was a student whose ID was 1. So if SID is 1, then we can simply print the college ID for Chef, right? So if SID is 1, then we can simply print college ID, and we will set found equals to 1. And after that, we will again set this allotted college ID equals to 1, and we can simply break this inner loop. So after this inner loop, I'll check if found is equals to 1 or not, which means that if Chef got his college or not. So if found is equals to 1, then it means that we need not to check for any more students, and we can simply break this outer loop too. So after that, we will check if found is equals to 0 or not. That is, if Chef got his college or not. So if he didn't got his college, if he didn't get his college, then we'll simply print 0 over here. So this completes the whole code. So let's just submit the code. So paste. This is the same code, right? So let's just submit it. I think this might take a little time over here. So we got the correct answer.